Hello and welcome to What's Bubbling at ZIM. I'm inventor Dan Zen. In the last couple bubblings, we've been talking about the ZIM particle emitter, so a new ZIM emitter. And the last one we saw some code. We started off on some of the basics, but we did not get finished because there's lots of things to take a look at. So in this one, we're going to revisit that code and keep on adding some more things. Okay, so let's go to that code now, the ZIM particle emitter. Now, ZIM at ZIMjs.com, you can go there and there's a particles banner, I guess you'd call it, and go in and click on that and see all sorts of different particle emitter examples. So we looked at that in previous bubblings. You're welcome to start there if you've just sort of arrived. We're using the new ZIM 5, and we had already started an emitter. So here we are making an emitter. We're passing in either a rectangle or a circle at this point. We were randomly making that rotate. Obviously, we won't see too much of the rotation of the rectangle. By the way, we just set a rotation of 45. We could have done that right on the rectangle itself just by going dot rot 45 like so. So this will then pass in a rotated rectangle as something to make a particle from, and then we don't need the rotation here. We save that and check it out in the browser. So that's oops, not that one. Ooh, Windows Ink Workspace. What is that? Not the Windows key, browser, Control W. There we go. And now you can see that we've got these diamond shapes because we've passed in the 45 degrees there. So if we don't do that, save that and try again, refresh. Those aren't diamonds anymore, they're squares. Ooh. Along with the random here, we're trying to get to the point where, oh, well, how could we make these rotate, for instance? So we can say, let's randomize the rotation, first of all, and just start off random. And that is rotation colon. And if we want anywhere from 0 to 360 like this, 360, oops, that's an object, then we need to use the object literal format here, min and max colon 360. So for instance, just to tell you the difference, 0, 360, that is an array, like so, and that's a valid ZIM v value. It will pick then between 0 and 360, which happens to be the same, so it's not going to be much help. So with a rectangle, it's not going to be, there we go, 0 or 45. Right now it'll make either zeros or 45s. But if you want a range, then you go to the ZIMrand object format. And that's also a valid ZIMv, and so that gives us a range of a min of 0 to 360. So now these things will start off at a variety of rotations. And you know what? Let's get rid of the gravity here. And, the angle, I suppose, is fine, but we'll make less of a force. We'll make a force of 1, just so we can see some of these things a bit better. And we'll save that and take a look in it in a browser. Oopsies, I think I forgot a comma somewhere. There we go. Comma. Try that again. And gravity's still going. Oh, right. My apologies. Gravity by default is 9.8. So if we delete gravity, maybe that's what I should have called the sink. We've got this thing called the sink, which attracts things. I could have called that the gravity. But anyway, gravity colon 0. We have to explicitly set the gravity to 0, otherwise it will be 9.8. All right, so yes, there we go. So now as these emit, you can see that the rectangles are randomly rotated. Shall we make these just a bit bigger so that you can see their shapes? I'm not sure. Usually particles are small, hey, little particles, but they don't have to be. We can make those big. What else about them? We got a life, sure, a number, they're emitting fine, a force of 1, guess that's okay. And let's take a look at them a little bit bigger. Oh, they're only shooting up, which is a little bit odd. Let's just lose the angle of it. This is the angle that they're shooting out. And the last time we said, hey, let's make them go up. And that's what that does. Okay, so save that. Tab. Now they can kind of go everywhere. So there they are going everywhere. And you can see that those rectangles that are coming out are randomly rotated. How about we say frame.gray? Once again, that can be any CSS color, you know, like quote. It could be quote gray or quote number sign 33333, you know, that kind of thing. But we've stored the ZIM colors on the frame, and that's what we're using here. And so what we're doing is giving it a border or a border stroke. Okay, in both cases. And those are coming out randomized now in their rotation. Super. And now what we want to do is animate them, make them turn. So we can pass in an animation object, and that will be just like ZIM animate. So this is, you can pass a configuration object to ZIM animate, and that's what we put in here. So this can be many properties. The animation object is here now, we're specifying. We can also specify, I'll come back to that, we can also specify, for instance, the time, and we'll make that 5,000. And we'll, if we're rotating this, so rotation colon, make that 360. So what we're doing here is, if you said rotation without these brackets of 360, this goes back to ZIM animate. This is how ZIM animate works. It's something new in ZIM 5. And that is, you can specify 360, but what will happen is they'll all animate to 360 degrees from wherever they are. So we're putting a random rotation, and they're all just going to animate exactly to 360 degrees. Not from where they are currently, but to 360 degrees. So if you want relative rotation, now we've introduced this in ZIM 5, you can put it in quotes, and now it will animate 360 degrees from its current rotation. Cool. Now whenever you rotate, and we're going to loop as well, so put loop colon true. Whenever we rotate, it looks silly if you have the default easing. The default easing starts off slow, speeds up, and then slows down, sort of thing. And if you're going around in circles, it's like so you don't want the ups. So that means you should set the ease to linear, comma. Oops, not quite right. One of these things, not quite needed. Linear, there we go. Gosh, I sounded like my mother. My mother singing is, oh, exuberant, we'll call it. But hopefully she's not listening to these. Does your mom code? Anybody know? Anybody have a mom that codes? Soon they will, hopefully. Okay, so we save that up and refresh here. And now you can see that we've got these things spinning. They're all spinning the same way, but that's kind of cool. They're coming out at different randoms, and they're all spinning, but they're spinning in the same way. Did I say a different way? I meant they're all spinning in the same way. We want them all spinning now to go, one spins this way and one spins that way. All right, so to do that, we can pass in a ZIMv value right here. So instead of only 360, we can say 360, comma, you know what we're going to say? Minus 360. And so that will rotate it around either 360 or minus 360. So we save that up and take a look, refresh here. Can we tell? That one's spinning backwards and that one's spinning forwards. Yeah, look, backwards and forwards. Cool, huh? All right, how about a bit of a thicker, instead of gray, we'll go dark. Like that, and dark over here, dark, dark. There's also darker. Okay, super duper. We've got some particles. They're all heading off in different ways. What should we do now? I mentioned in the last time that we should take a look at the trace. Trace is a neat option that will allow us to trace the path of these. Why don't we just turn it on? Are we good? Good so far? Yeah, okay. So I'll pop up just above the interval, and we will say trace colon true, comma, and we'll see some exciting things here. Kind of exciting, a little bit ugly or something. And what's with this square that it's doing? Okay, so one thing is, because it's moving slowly and we have a border on it, it's not tracing quite as nice as it might. It's sort of neat, actually. It's twisting. But what's with this border that we're seeing here? Why is it stopping there? That's because the default size of the emitter, the width and the height, is set to 300 or something. So we've got 150 pixels this way, 150 pixels up, etc. So by default, these things come out in the middle. Unless we say horizontal or vertical. If we say horizontal, they'll run horizontally along the top. Okay, so that's one thing. Now, before we fix the size of this, maybe we can take a look at that horizontal vertical thing. So let's make them just drop down from the top. To do that, we would say the horizontal means run them along the horizontal, and then set that to true. Let's make them go in their angle. Let's make them go down. So that would be 90 degrees because the angle is 0 going along the x-axis, positive x-axis, so 90 is down. So that will drop them down 90 degrees from the top, and we save this. Take a look. So there they are in there, dropping down from the top. Now, we should oh, I see, just the corners are showing. I was wondering why we're getting little edges kind of showing there, but as this thing rotates, perhaps it doesn't matter, but let's just stop the rotation so I don't get confused. So we're not randomly rotating, and we won't do that animation of the rotation there. Isn't that neat? Like when you set these things on multiple lines like that, it's easy enough to just comment out parts of it, and that works just fine. So that would be my recommendation. And bring that, and there we go. It's a bit simpler to see. You can also see that they're popping on the screen right at the very top. So they just go boing, 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 boing. You might get half of them because I think by default it's center regs. It puts a registration point in the middle, so you're getting half of a square sort of thing. So we will want to be able to accommodate that. What else can I say about this? We should change the width and the height, though. So let's adjust the width and the height now. Width colon stage width. Oh, let's just do that one and see what happens. So that's the stage width there. And now they're falling across the stage width, perhaps. If we get over the, I can see that. They're sort of randomly falling into places there. And you can see that the height is not quite working for us. So height colon stage height, comma. Good. They're still popping in right at the top, and that's what I wanted to get at. Also, they're running out of steam before they get down to the bottom. We could increase the life, but we might want to also increase the force, or indeed just let this work with gravity. Well, since we've got a force here, we'll just do that. So we'll make it 5. Now you can see the effect of the frame rate and stuff like that. We're making the force bigger, and so the frame rate is causing this to separate in a sense. You know, we're at 60 frames per second here, so we're not going to do much better. There is a way to draw lines, and the lines connect, and we'll show you that maybe in the next What's Bubbling. Okay, so those are all shooting along, and you can make that faster, for instance, a force of 10. It's coming close to gravity. Okay, and even faster and get different types of trails. But we're still getting that popping happening at the top, and that's I just wanted to fix that, where half of the thing is popping onto the screen. And to fix that, you just, instead of center reg, well, you center reg and then you dot move. You would move it up. Center regging, that could cause a little bit of a problem. We'll talk about that in just a sec. So if we move this up, how about 0 in the Y then, and negative 20 or something like that, and refresh. Yeah, good. Now they're starting above the screen and falling. Oh, but look at our bottom. Our bottom now is cut off. Okay, so that's the caching rectangle. What it's doing is each one of these lines, you see how each one fades individually? I don't know if you can see that in there. Each one is being put in a container and then drawn onto the container with a composite operation, some blend mode. Okay, and so it's being cached at the same dimension as our width and height. Okay, which means we have that much room to look at. It also means that we're using too big a size really to cache that thing. But anyway, we can, I wonder if I could fix that. No, because if you go at any other angle, you're going to have problems. But there are some things that we can do with that I'll show you because they're rather subtle. In this case, though, we just want a bigger height. So we've moved it up so that it starts off the screen, but we just need a bigger height than the stage height so that it will go off the screen. If we go with our height of stage height plus 20, let's see what happens. It seems to me that would make sense, but probably won't quite work. See how it's still not working? That's because we're center reg. So half of that is going on one side and half of it's going on the other side. So really we could just say add to the stage here. Now let's see if that works. There we go. So if we add to the stage, it's not center regging it, and that 20 is going all to the bottom. But I mean, you can play with that. That's just minor mathematics. Minor mathematics. So isn't that cool? All that stuff shooting down with trails. So what's next? Maybe that's subtlety. Let me describe the subtlety now, and then perhaps we'll end this one and we'll move to the trace. Well, we could maybe do the trace now. Let's end this one and we'll move to the tracing with this is trace, but tracing, sorry, with the lines with by putting things in a shape. Okay, so we got to trace and let's make it go out at random angles. We'll take away the horizontal. Well, tell you what, we'll comment out these guys. What should we do with the width and height? Let's just make the width and height. Let's go back to default on the width and height, just to sort of touch base with the default. We've got a life, we've got decay, time. I'll reduce the force a bit to slow things down. Trace true. Okay, so now we're going to trace and we'll center reg. Center reg. There it is. And we won't bother moving. Okay, let's take a look. So now we've got these things shooting out and hitting the edges. Now say we were doing something like always shooting them to the right or something like that. So let's just adjust the angle here to be from a min of -90, comma, and a max of 90, like so. Let's try this. So there they're all shooting this way, and this comes into effect, say, in fireworks where you shoot them up, but they shoot up and then they all fall down. So they go up a bit, but primarily they're going down, imagine. Here we are, we're inside of a width, and height here, but we're only using half of it. Now that means our caching rectangle over here is not really needed. I mean, we're wasting that, and that will affect your performance. So what we would really want, and let's bring this up to the height of the. So that's the height of the stage, like so. And save this and run it again. Okay, so we're now going to the height, and we'll, if we make it a width of half the stage, then it doesn't quite work. So let's try that. That sort of looks like what we want to do. Divide it by 2 and refresh. So we've made it a width of half the stage because that's really all we're going to need. We only need to work on this half the stage. But unfortunately, since the particles are positioned in the center, we're getting it half of it's here and half of it's over on this side, and yet we're not using any of this. So what I'm getting at is we can shift the caching rectangle over. So we can keep the same width and then shift the caching rectangle over. So to do that, it is, it's called the, well, you know what? I almost can't remember what it's called. Why don't we, hey, this is a good time to take a look at the docs and see what other kind of features we can do. Alrighty, so let's go to the docs. Like so, type in emitter, emit, and there they are right there. So there's trace. Can you see that okay? There's trace fade time, trace shift X, and trace shift Y. So we're going to want the trace shift X, and we're going to want to move that over, trace shift X, and we're going to move that over the stage width. Not divided by 2, but divided by 2 divided by 2, or divided by 4, comma. And let's go back and try and save that, and tab on over. Okay, and refresh here. There we go. So what's just happened, oh, there's a little bit of an issue, is we've taken that width, which was on both sides, the half the stage width, right, that ran this way, and we've shifted it over half the distance, so half the stage width again, and now our half the stage width is all acting over on this side. But take a look, there's a bit of a problem right on the edges these are being made. So we can't shift it quite that much, so minus 20 or something like that, and that means we also need to make the width of it plus 20. And let's see what happens. So we're good there. Oh, not quite good there. The width, oh, is going on both sides, so we're going to have to double that. Perhaps something like that. And there it is going off. Okay, so like I said, that was a bit of a subtlety, a good place to kind of end this one on something a little bit complex, where we're adjusting the caching rectangle of these to make optimal use of our positioning. And this is something that we did in fireworks as well, because fireworks start up at the, you know, they start kind of where they explode. They go up a little bit, but not all that much. And then they're coming way down with gravity. And that coming way down with gravity, that's where primarily, you know, we put the caching rectangle down there. Neato mosquito, do you like that? Let's just quickly change the alpha of that just to show you what that might look like. Here are our things that we can change the alpha of the whole emitter because it's just a container, or we can put the alpha change here, .alp, like that, and make it 0.1 and 0.1 here as well, .alp 0.1. So, and try this out. Well, maybe that was a little bit much, but you get the idea. Isn't that kind of fun? And there's all sorts of things that you can do with the emitter. And we will come back in another bubbling, maybe we could even make some bubbles. Sure, you could make bubbles with an emitter. What's bubbling at ZIM, and take a look at more coding, including the tracing, but working within a shape. so that you get lines rather than these sort of stamped shapes. Also, we have a sync and a wiggler to take a look at. Woohoo! Ciao!